Light isn't just something we see, it's something we interpret, a messenger bearing coded information about the cosmos. And the more tools we build, the more we realize light doesn't merely illuminate space, it translates it. Some photons travel from the depths of exploding stars, supernovae, carrying signatures of heavy elements forged in cosmic furnaces. Others bounce off oil slicks and soap bubbles, painting rainbows through interference and refraction, revealing the hidden geometry of how light waves interact. This diversity is what makes light such a powerful communicator. It doesn't simply show us what's there. It helps us understand how and why it's there. For example, when white light is passed through a prism, it splits into a vibrant spectrum of colors. This moment of beauty is more than just a visual delight. It's proof that white light is actually a blend, a symphony of wavelengths playing in perfect harmony. And when we pass the light of a distant star or galaxy through a spectrograph, we reveal even more. The composition, temperature, motion, and even the presence of planetary systems. Each element leaves behind a spectral fingerprint, a unique pattern of absorption lines. In this way, we can know what stars are made of without ever visiting them. Think about that. From right here on Earth, we've determined the elements inside suns billions of light years away, just by reading their light code. And as technology evolves, so too does our ability to listen to light in all its forms. With radio telescopes, we detect the faint signals from hydrogen clouds, the building blocks of galaxies. These emissions are so weak, so ancient, they would go unnoticed without massive dishes stretching across deserts and mountaintops. With X-ray telescopes, we peer into the high-energy hearts of galaxy clusters, where black holes churn and collide, producing rays so powerful they would fry electronics on Earth, if not for our atmosphere. With infrared telescopes, like the James Webb Space Telescope, we look through cosmic dust clouds, regions opaque to visible light, and watch as new stars are born. These are baby suns forming in hidden nurseries, invisible until we tune our vision to the right frequency. Each wavelength of light unveils a different layer of reality, like turning pages in a cosmic book. But our sensing hasn't stopped at light alone. We've now begun to detect gravitational waves, ripples in space-time itself. These aren't made of photons, but they act as a complementary cosmic message, confirming what light has always whispered. The first detection of a neutron star merger in both gravitational waves and light was a milestone. It showed us two messengers arriving from the same event, telling a fuller story. Together, they paint a picture of a universe that is not cold and silent, but alive with signals, waiting for us to understand them. And as we listen more carefully, we learn to ask deeper questions. What are the limits of light as a messenger? What if there are forms of radiation, or even entire spectrums, that we have yet to detect? Are there cosmic signals traveling at different frequencies, through dark matter or even exotic dimensions, that we can't yet tune into? It's possible, but for now, photons remain our most faithful messengers. They cross billions of light years without tiring. They curve around stars and black holes. They shift and stretch as the universe expands. And still, they carry meaning. From the brilliant flash of a gamma-ray burst to the cool glow of a nebula, light tells us everything we know about the universe outside our tiny home planet. Even on Earth, light is our guide. It tells us when to rise and when to sleep. It triggers the growth of plants through photosynthesis. It fuels our energy cycles, our emotions, our understanding of rhythm and time. Light is a constant companion, flowing through every device we touch, every image we capture, every equation we write. And it's humbling to think, even with all our technology, all our equations, we've only just begun to understand it. At Infinity Beyond, we believe that every photon has a story. And those stories, when woven together, form the fabric of everything we know. So the next time you look at a rainbow, a sunset, a telescope image from deep space, remember this: you're not just seeing beauty. You're reading reality. You're decoding the very structure of the cosmos. In the next and final segment of this journey, we'll bring it all together, following a single photon's journey, from its birth inside a star to its arrival in your eye. A tale of fusion, escape, and the miracle of perception. Until then, keep looking, keep listening. The light is always speaking.